All right. In the last class, we have studied the glass working. Actually, a lot of glass working processes, and the last topic was forming of glass fibers. And today we are going to finish this lecture with the heat treatment of the glass. Okay. So for the heat treatment, why do we need heat treatment? First of all, heat treatment is necessary for strengthening or modifying the properties of any material. For in the case of materials, for any material, if you want to change its thermal, physical, electrical, or mechanical, any other properties, then we need to do the heat treatment. This is the best way to modify the properties. Also, the manufacturing parameters sometimes affect the final property of the product, but the heat treatment is widely used process for any material uh, to modify the property. In the case of glass, what happens is that most of the glass products are subjected to when you manufacture the products, they are subjected to compression force. Okay, sometimes they are subjected to the shear force during the extrusion. Okay, for the continuous manufacturing. In that case, what happens is that inside the glass, the undesirable internal stresses are formed. Okay, when this undesirable internal stress means actually the glass is an amorphous material. Okay, and it doesn't have the continuity of the molecules inside the material, and they're distributed randomly, and that also causes undesirable internal stress. But when the glass is subjected to the compressive force or the shear force, and after solidification, that force actually remains inside the material, and it causes the internal stress. That means sometimes that internal stress becomes the cause of failure. That means the failure actually starts in those points where the internal stress are much higher. So in that case, we need to reduce this internal strength to get the long life or the stability of the material. And annealing is one of them, one of the heat treatment method which is used to modify the property of the glass to give it a little bit of ductility, because the glass is very brittle material. So if we can relieve some internal stress from the glass, then it becomes kind of a little bit of ductility is introduced into the material, and the annealing is used for that purpose. So what is annealing? Annealing, I think most of you have studied annealing during your metallurgy course. It's kind of similar here. That means you have to heat the glass at an elevated temperature, uh, not the melting point temperature, at some recrystallization temperature where glass molecules can reorganize themselves, and holding it at that for a certain period to allow the glass molecules to move around and fix their spaces and become stable, and and that will cause the elimination of internal stress and the temperature gradient. The temperature gradient is in another region why the internal stresses are formed. For example, if you consider a glass sheet extruded from a die, if this is a die, glass sheet is getting extruded from that die. If I say this is die and the product. So in that case, what happens is that if we introduce the cooling cold air from the outside, uh, the which portion of this sheet will be this is the direction of extrusion, which the outer surface of the glass sheet will be cooled down first. The temperature in the outer surface will be less than the temperature in the inner surface. That is, surface temperature will be inner surface will be cooled slowly compared to the outer surface, and this is the temperature gradient. If you float the temperature will be like this. Okay, the outside temperature is very small, and at the middle the temperature is high. So there is a temperature gradient. Okay, and this temperature gradient actually is another region for developing the internal stress. Okay, and to relieve that internal stress, we have to increase the temperature of the whole material to a certain temperature and keep it at that temperature for some time to move the molecules and keep become uniform, and then we slowly cool the glass to suppress the internal stress formation, and internal stress will be removed when the temperature of the material reaches the room temperature. And common annealing temperature is like 500 degrees Celsius for the glass, and the required annealing time actually varies. The annealing time varies with the square of the thickness. That means if we write the equation, T is equals to thickness, if you consider the D is the thickness square, kind of this, the time is proportional to the D square. There's some there, if we equate it, like K is a constant, D square, something like that. The annealing time varies with the square of the thickness. When if the thickness of the material is high, then annealing time will also be high. That means the certain period that we have to hold at that temperature, that means 500 degrees Celsius temperature, we have to keep it for some time, and it depends on the thickness. If the thickness is higher, then the required amount of time for annealing will also increase. The annealing in modern glass factories actually performed in a tunnel-like furnace called layer, okay, in which the products flow slowly through the hot chamber on conveyor. That means it's a kind of continuous process when glass sheets are coming out of the die, and then it moves through the annealing chamber, where it's a very long chamber where the temperature is kept like 500 degrees Celsius temperature, and then the annealing how long the glass will be inside that furnace will depend on the thickness of the material. If thickness is higher, then the annealing chamber length is small, and if the thickness is lower, then the annealing chamber thickness will be smaller. That means it will stay in the annealing chamber for a small amount of time. Okay, do you have any question? Okay, then we'll move to the next one. The next one is
No,
that
sir.
to increase the temperament of the glass, not only the ductility of the glass or the removing the internal stress, but we can also temper the glass. That means we can increase the energy absorption capability of the glass with the heat treatment. Uh, if we do the tempering, like it's a kind of heat treatment process that causes the internal stress pattern. That means for the metal, if we consider the tempering, it's like uh, heating at a certain temperature, keep it at that temperature for some time, and then cooling at a certain rate, and then we get the tempered material. Something like that happens in this case too. uh, as the treatment of hardened as in the treatment of hardened steel, tempering increases the toughness of the glass. That means this process is almost similar to the annealing, except that the cooling is rapid. Okay, for the tempering process, cooling is rapid. After certain time, keeping at high temperature, and then you cool it. The process involves heating the glass to a temperature above the annealing temperature, and then plastic drains, followed by quenching of the surface, usually with the air jet. That's what I was telling. Like you raise the temperature to a certain degree Celsius. That means more than 500 degrees Celsius temperature, and then you keep it in that temperature for some time, and then you quench it. That means you remove the heat quickly. Okay. Okay, I think Burhanuddin has a raised hand for.
মানে টেম্পারেচারটা স্যার মানে ভেরি কুইকলি হলে স্যার মানে কুলিংটা হলে স্যার বিটেল করতে পারে না, ফেল করতে পারে না স্যার এটা
Yes,
গ্লাসটা?
of course it can make it brittle if you, it depends on what temperature you are working on. For example, if we consider the metal, like steel, then what happens is that you raise the temperature to the to produce the austenite, and then you keep it in the austenitic state for some time, and then you rapidly quench it to allow the reorganization of the material. The same thing actually happens in here. The quenching actually does not mean that you are rapidly cooling to the room temperature. Okay, the quenching has many different ways to do the quenching or tempering. Okay, for steel, if we consider like do the tempering can be done in many different way. For example, for metal, if we produce the austenite, and then we rapidly cool to the 400 degrees Celsius temperature. we keep it at the at 400 degrees Celsius temperature. Then this causes actually a different property if we cool it to the directly to the room temperature. So there are many different way of tempering. For what happens for the glass is that we usually use with air jets. Okay, air jets are used for quenching, and for the brittleness, or it depends on the cooling from melting point temperature to the room temperature. And in this case, the heating the glass to a temperature somewhat above the annealing temperature. Annealing temperature is not the melting point temperature of the material. Okay, so this cooling will not be similar to the cooling from melting point temperature to the room temperature rapidly. Did you
Okay, sir.
understand it? It's different. Okay. So when surfaces cool, they contract and harden while the interior is still plastic and compliant, and the internal glass slowly cools. It contracts and thus putting the hard surface in compression. And like other ceramics, glass is much stronger when subjected to compressive stress than tensile strength. So what actually the summary of this is that when these air jets are applied on the surface of the material, air jets are applied on the surface of the material, the surface actually cools down first. Okay, surfaces cools down first, and internally this material cools slowly. Okay, and in that case, what happens is that surface is formed and becomes solid, and then when these materials cools down, they actually shrink. Okay, when they shrink, they produce a compressive stress because of the harder surface on the outside. Okay, these two surfaces goes towards their opposite direction, and then the internally these materials become compressed, and that's why it increases the toughness of the material. Okay, at the same time, there is another benefit, which is on the surface the material is hardened and it's very hard. You'll get the very hard surface with a soft coat, and that causes the that is what the tempering is done is about. And the tempered glass is much more resistant to scratching and breaking. It's because this internal material in the inner core is kind of ductile, because they cooled slowly, but outside it is hardened. The internal one provides actually the required toughness, and the outer surface provides resistance to scratching. That means it becomes very hard. Okay, this the combined effect actually gives that tempered benefit. That means the high energy absorption capability of the tempered glass. And the application includes actually the windows for tall building, all glass doors, safety glasses, etc. Okay, any other question? All right.
Sir,
Okay, Abdullah.
sir, is there any difference between cooling and quenching,
uh,
sir?
Quenching, the term quenching actually used, it's
Cooling.
cooling. Okay, it is cooling, but quenching, this term is especially used for
Yes, sir.
heat treatment purpose. Okay, because quenching does not mean the simple cooling.
Yeah.
It means you can cool it at various temperatures. Okay, that's why it's a different term. Just it is cooling, but especially used in the heat treatment. Okay.
স্যার
Yes.
স্যার
Yes.
স্যার উপরেরটা যখন হার্ডেন হচ্ছে তাহলে এটা
Okay.
হচ্ছে আর ভিতরেটা যেহেতু সফট থাকতেছে সেই ক্ষেত্রে কি ম্যাটেরিয়াল গ্রেন গুলা তো ভিন্ন ভিন্ন হওয়ার কথা, সেই
No, no,
ক্ষেত্রে ভিতরেরটা টাফনেস কে দেখাচ্ছে, উপরেরটা হচ্ছে স্ক্র্যাচের জন্য বললেন, তাহলে কি স্যার এই দুইটা কি লেয়ার হিসেবে কাজ করে?
yes, there will be two different layers, not actually complete layers, because the if you consider just hang on a second. For example, if you consider a plate like this for a certain thickness, the outer surface, when you use the air jet for cooling, okay, the outer surface will be cooled down first, and then slowly the inside will be cooled. At some time, these materials will be more molecules or atoms will be more randomly distributed compared to the inside materials. Okay, that's why the outside surface provides more hardness, and inside surface they have sufficient amount of time to reorganize, and they will have less internal stress. Okay, and that is why the inner core will provide the toughness, and it's not like a certain layer. Okay, concrete layer, it's gradient. Okay, it will if you consider like if you plot the hardness of the material, then the hardness at the surface will be higher, and then at the core it will be minimum, and then on the other surface it will be higher. And in terms of toughness, if you plot the it's like a hardness, okay, and if you plot the toughness, then it will be like something like this. The toughness will be on the surface will be less, and inner core there will be toughness will be high. Okay, it's a gradient, not a single layer. Okay, did you understand?
Yes,
That's
sir.
okay.
Yes, sir.
Oh, all right. And tempered glass and related products. When the tempered glass fails, what happens is that it does so by shattering into numerous small fragments. If you break the ordinary glasses, they don't become the very small fragments. They become like a chunk of glasses. Okay. For example, if I show it here, for example, you have a piece of glass, something like that, and it's not tempered, then what will happen is that it will break like this. Okay, chunk of glasses will be produced. Okay, but uh, these are most likely, okay, sorry, this happens for the normal glass. Okay, for the normal glass, it becomes like fragmented into different pieces. But when the tempered glass is shattered, what happens is that it produces very small grains of the glass when it breaks. Okay, and the benefit of this is that uh, these glasses has the sharp corners which can easily cut, okay, the people's hand, or if you touch them, it will cut your hand. But when it becomes fragmented, it is less likely to cut someone. Okay, did you understand this? Anyone?
Yes, sir.
Okay.
Yes, sir. Yes.
In,
This is very interesting.
yes, and the more interestingly, automobile windshield. Okay, actually, automobile windshields, tempered glass is much more beneficial in terms of affecting people, isn't it? Normal glass has a chance to cut people's hand or skin, but
Yes, sir.
tempered glass is less likely to cut people. But
Hmm.
so,
If we think that
okay.
if we think to repair it or use it as recycling, then normal glass breaking can be more useful, I think.
Actually, for recycling, this is much more useful in terms of harming people, actually. And if you consider the recycling, in that case, what happens is that uh, either it is tempered glass or it is normal glass. What happens is that you have to make them like powders. Okay,
Powders. Yes, yes, sir.
so I think there is not much in terms of handling. This is much more beneficial for tempered glass. It will have less chance to cut someone or affect someone, but compared to the normal glass. Okay.
Sorry, can I add, sir?
Yes, yes.
Sorry, in case of emergency, automobile has we have some facility to break down the glasses. So if we can use the tempered glass, then it is much more easier to break down the glass and make a safe exit.
Yes, Tasnim Rana, you are right. The thing is that for windshield, actually, we don't normally don't use tempered glass or normal glass. Okay, tempered glass is used only for safety exit. If you look at the modern automobiles or buses, you will see there are some spaces where emergency exit is marked, right? In that place, the glass is actually the tempered glass. Okay, or sometimes for uh, uh, for easy braking, the tempered glass is much more useful, and sometimes for reduced cost, people use normal glass in that place for the safety exit. Only that window, the safety exit window, is made of tempered glass or normal glass. But the other glasses, actually not the tempered glass or normal glass, they are actually what it's called is like what's the name, um, laminated glass. Okay, it's kind of laminated glass. Yeah, sorry, it's a conventional glass is used. However, it is fabricated by sandwiching two pieces of glass on each side of the rough, tough polymer sheet. That means it is not actually glass, it's a composite. Okay, sandwich structure, composite sandwich structure. What happens is that on the there is 3 layer. Okay, the inner layer is actually a plastic, transparent plastic. Okay, inner layer is a transparent plastic, and the outer layers are either normal glass, or to reduce the cost you can use the normal glass, and or you can use the tempered glass. And the benefit of this is that using this plastic is bonded with this glass. The benefit is that when it breaks, okay, should the laminated glass fracture, if the fracture, glass splinters are retained by the polymer sheet. Since the glass splinter, the glass is attached to the polymer, and what happens is that when it breaks, these fragments are actually attached with that polymer. So there is a less chance for the fragments to split, okay, or sprinkle, or hurt someone's eyes. Okay, so this is the benefit of the laminated glass.
This is a bulletproof glass or something like this.
In terms of bulletproof glass, that is also a laminated glass. Okay, the glass breaks, but that polymer sheet that's present in between this glass is unbreakable. Okay, did you understand, Rana?
So yes, sir. Thank you, sir.
Okay, so this is all for the glass working actually. And do you have any question? If not, then we'll move to the next slide.
Treatment.
Okay, can you see the slide?
This.
And the new topic of lecture 2 is shaping process of plastic, how plastic products are made and where these products are made, and what are the characteristics of those machineries. We'll discuss that. Actually, this is a huge field for the shaping of plastic. It's a very huge field, but it is not possible to cover all of them in a 3 credit course. Okay, in that case, I think you have to do some more study. If you want to learn more about this, then you can use the recommended books to learn more. But I'll try to touch the most important ones and to give you an overview of this plastic processing. Okay. For example, if I talk about the extrusion process only, it will be like 10 to 20 classes. I think I will not be able to finish the extrusion if I want to give the complete details of the extrusion process. Okay, so I think I will give the overview. I will try to touch all of the processes so that you can have the basic idea of shaping processes of the plastic, and then if you have more interest, then you can learn more things out of this overview. Okay. So for the introduction, the plastic can be shaped into wide variety of products. I think nowadays it's increasing and increasing and increasing. It's continuously increasing process. Like in terms of volume, there are 80 to 90% products are made of plastic, I think, nowadays. So
Yes.
like molded parts, extrusion sections, films, sheets, insulation coating for electrical wires, fibers for manufacturing composites, or sometimes the clothes. Fibers are used for clothes, like polystyrene. Do you remember? We used to say like polyester shirt or polyester shirt. This kind of terms we use. These are very low cost. These are actually plastic. When you bring them in front of the any flame, they actually melt. Okay? But in the case of cotton, they don't melt, they burn, and this polystyrene clothes actually melt. Okay, and various polymer composites are also produced using plastics. And this lecture introduces the technologies by which these products are shaped or made. How these products are made, then we'll discuss about all of this. And actually, there are 2 types of plastics. can be three, including the rubber or elastomer. One is thermoplastic, which in this case, in the case of thermoplastic, the chemical structure remains unchanged. That means before after solidification, melting and after solidification, the chemical structure does not change. Okay, but they become solidified. And more importantly, it is very important commercially, and most like 70% of the total plastic are these thermoplastics. It's very easy to handle and easy to manufacture. So more tendency to use these plastics for producing the plastic parts. And thermosets, actually, what happens is that after heating, during heating and shaping, the chemical change occurs. There is a permanent change in the molecular structure once cured, and they cannot be remelted. If you want to melt again, then it will not melt, it will actually burn. Okay, so in the case of thermosets, you can only melt it once to produce the product, and once the product is produced, then you have to you cannot remelt it. You have to go through a lot of other processes for recycling. Okay, but in the case of thermoplastic, it's very easy to remelt. That's why thermoplastics are mostly used and they are recycled. The shaping processes actually include like extruded products, which are sheets, films, or filaments like fibers, or the poly bags or polythene sheets, okay, and that are used for building construction or insulation. And continuous sheets or films, then filaments, molded parts. That means you want to produce like various household items or plastic toys, or molded parts. Hollow molded parts, if the molded part is hollow inside, then with thin walls, okay, like plastic balls, something like that. And discrete parts made from sheets and films, and the casting and foamed product. The foam PVC boards are currently being used for decoration of various stores or household decoration, or even these foam products are being also used as the roof tiles, okay, or ceiling tiles, if I must say ceiling tiles. And the first we'll start with the extrusion process. The extrusion is nothing but a continuous process of pushing the molten plastic material through a die. Okay, and the final product, the dimension or cross section of the final product will depend on the characteristics of the die. That means if the die is circular, then final product will be cylindrical. If the die is triangular, then final product will be triangular or rectangular. Okay, it depends on the die characteristics, or you can also produce like C channel using these dies. If the die is like C channel, then the final product product cross section will be like C channel. But it's not that easy actually to produce. The circular one is very easy, but the square, triangular, or other complicated sections are not that easy. I'll talk about that. And in this case of extrusion, this is a single screw extrusion. Sometimes there for more advanced production, people use twin screw extrusion. Okay, it says TWIN, twin screw. Twin screw extrusion is also used for better production and for better mixing of the materials inside the screw. And it is a continuous process. That means you continuously add the plastic resins. That means plastic resins in the form of granules. Okay, this kind of small granules are poured into the hopper, and along with other additives. Plastic resins are not only the product, only raw material used for plastic product manufacturing. There are some other materials also needed to be added. For example, if you want to color it, like these plastic pellets are actually kind of not sometimes colored, sometimes not. And if you want to add additional color or change the color, then you have to use color. And then also you have to use plasticizer Plasticizer is used mainly for increasing the flexibility of the material. If you want to be the final product to be flexible, like you want to bend it very easily, then you use the plasticizer, or otherwise if you want to produce the rigid plastic, that is very strong plastic, then you have to reduce the amount of plasticizer in the material. Okay, sometimes these plasticizers are included in the resin grains. Okay, sometimes not, you have to use it manually. Okay, and other thing is that if you want to modify the plastic for the production of composites or something like that, then you can add the fibers or nanoparticles. These things are added in the hopper. Okay, these are the raw materials for the final product. Okay, so when raw materials are added through the hopper, it's a gravity fed. Actually, there is no external means of feeding these particles. These particles are solid particles, and the mixture is poured into the hopper, and then it moves to the screws feed section. In the feed section, if you look carefully into the image, the screw diameter is small at the feed section, and the diameter is maximum at the metering section. This is called metering section, and this is the feed section. The screw is divided into 3 different sections: feed section, compression section, and metering section. Okay, the diameter of the screw is small at the feed section and larger in the metering section, and the channel, the cylinder through which the material is passing is uniform thickness. The diameter is uniform all over the length. Okay, then can anyone say why this is happening? Why we need to have the larger diameter on the end?
স্যার এটা হচ্ছে ইনিশিয়ালি যেহেতু হপারের যে প্লেট গুলো দেওয়া হচ্ছে সেগুলো সাইজ বড়, তো এটা ইনিশিয়ালি এর জন্য ডায়া কম আছে, আর হিটারের মধ্যে দিয়ে যখন যাবে ওটা টেম্পারেচারে মেল্ট হবে, হওয়ার পরে ফাইনালে যখন যাবে তখন হচ্ছে এটার হলো কনসেন্ট্রেশন মানে বাড়বে, তো সেই ক্ষেত্রে আউটের ডায়াটা বেশি থাকবে ইনের চেয়ে।
Okay, anyone else?
Actually, sir, to increase the pressure and to increase the speed of the product, maybe, sir.
Okay, anyone else? Pranto, do you have any idea?
স্যার কম্প্রেশনের জন্য স্যার?
Yes, compression is one of them.
মানে টেম্পারেচার এবং প্রেসারটাকে নিয়ন্ত্রণ করার জন্য মূলত আসলে
pressure compression, it's kind of similar. Okay, the main thing is here is the main problem. If we do not use this compressed that means the gradually increasing diameter of the screw, what will happen is that there will be lot of pores, because we are using particles here. The particles contain interparticular gap, and that contains air, right? And if we do not compress it, then there is no chance that these air gaps are getting out. There is a provision to vacuum applied in here to reduce vacuum applied here to get those air out of this system. Okay, and when this diameter of the screw is increased, if the diameter of the screw is constant, there is no chance that particles will get out. The air particles will get out. Okay, then the plastic will be full of voids. The final product, if we look at the final product, then you will get like air voids into the final product. Okay, this is one of the reason to remove the air particles or gases from the melt. Compression is required. And second one is to increase the pressure or compression. Okay, if we do not increase the compression pressure, then the problem is the extrusion speed will be very low. Okay, the extrusion speed will be very low, and there will be a lot of other defects. Okay, when I go to the defects, I'll show you what happens for low speed or low pressure set here. And another thing is that there is a breaker plate. Okay, breaker plate, which is actually a mesh. Okay, a mesh screen, something like this. A screen with a lot of holes inside the in it. Okay. And what happens is that after when the plastic melts through the screw opening, and then when it comes towards this vent, if there is no sufficient pressure in here, then the material will not pass through this mesh. Okay, and it is necessary to keep this mesh in here, because sometimes due to the rotation of the screw, melting is not uniform. In that case, there can be some foreign particles also with the resins, and those foreign particles should not go into the product, and that's why this mesh is used. Mesh is used to is to screen the unmelted products that are not melt properly. It will be screened in this section. So the high pressure is required to flow the plastic through these holes, and that is why this because of these two regions, one is compression, another is removing the pores. Okay, these are the main two reasons for making the screw gradually larger diameter. Okay, and there are some heaters used. These heater is used basically for preheating, and then there is provision for removing the gases or air molecules, and then in the compression section, material gets compressed and pressure increases, more in the metering section. And in the metering section, actually the not only screw is used, but also there are some other attachments available which are not shown in here. In metering section, what happens is that if I go to the metering section, okay, I'll go to that in the next slide. Before that, I'll talk about something else. Like the inner diameter is typically range from 25 to 150 nanometer, 1 to 6 inch, and it's a very long screw. Okay, the length to diameter ratio is usually between 10 to 30 times. Okay, if the diameter is 25, 10 times the diameter will be the length. Okay, that means 250 millimeter will be the length of the screw. It has to be very long, because the heating to attain the proper heating also depends on the melting point temperature of the material. If the material melting point temperature is less, then it's kind of 10 is more than enough, and if the melting point temperature is high, then ratio should be high. And also depends on the material, like for higher ratio should be used for thermoplastics, and the lower ratio is for elastomers, because elastomers the bonding between the particles in the elastomer, that means rubber. Elastomer actually rubber. The bonding between the molecular chain, the bonding between the molecules are weak. Okay, in the rubbers. That's why lower ratio is enough for elastomers, and for thermoplastics the bonding is high, strong, and that's why we need a long travel of the molten material to get the proper heating and uniform mixing of the material inside the screw. Okay, and this is already discussed. Mixing and the screw rotation, it depends on the material. For various material the rotation is different, but usually 60 revolution per minute is the revolution used for screw rotation for moving the material. And it also depends on the pitch of the screw, how the material will flow and how much flow you require for also the size of the die. Many other factors affect actually this revolution of the screw. The higher revolution for constant, if other things are constant, then higher the revolution, then more will be the material flow rate. That means if we say the Q, mass flow rate or volume flow rate of the plastic will be higher if we increase the extrusion screw, the rotation speed. And it's the function of the screen that I said, the hard lumps from the filter contaminants. If there is contaminant or the material that are not melt properly, which can produce defect in the final product, these hard lumps are screened in the screen pack. That means in the mesh, and the build pressure in the metering section, it will increase the pressure more and straighten the flow. This is important, straightening the flow. When the material is flowing through the screw, the material actually rotating like a spiral. Okay, and if we use the mesh in here, that actually makes the material laminar. The flow becomes laminar. In this case, inside the screw, material actually have a spiral flow. Okay, and if we keep this spiral flow until the screw outlet, then what happens is that there will be several different kind of defects will be produced. The surface will not be smooth. The outside product, the product surface will not be smooth. That's why this turbulent flow has to transfer to a laminar flow, okay, before exiting the screw. And this plate actually serves that purpose, to reduce the movement history of the particle, to give them a laminar flow. Okay, did you get it? Any question?
স্যার এল বাই ডি যেহেতু 10 থেকে 30-এর মধ্যে, এটা কি ক্যান্টিলিভার বিমের মতো কাজ করতেছে না? তাহলে তো এটা ফ্রিকশন হওয়ার কথা এন্ড পয়েন্টে, যেখানে ডায়ামিটার বেড়ে গেছে স্যার।
Yes, it's very long, but the screws are connected with the at these points, you see, with the cylinder, so it's not going to be a cantilever.
Yes sir.
Okay, did I answer your question, Russell Khan?
Yes sir.
Okay
sir, it looks like a screw type pump, I think.
Yes, it is actually a pump. Okay,
Yes sir.
Okay, so for the screw is divided into 3 sections that I have already told you, like a feed section where the material is preheated and then compressed. In the compression section, we compress it, the pellets extracted from the melt, the air is extracted from the melt in the compression section. At the same time, the compression of the material occurs to remove the air, and then metering section, it actually homogenizes and develop sufficient pressure to pump it through the die opening. Since the die opening is smaller compared to the screw region, that's why you need sufficient amount of pressure. Okay, and homogenization is also important, because if we mix different type of material and that is not properly homogenized, then some portion of the plastic product will be like brittle and some portion will be like plasticized. That means it will be flexible. So the homogenization is very important. Okay, and that's what occurs in the metering section, where it's not actually shown in this screw. It's kind of a mixture is placed in here. Okay, this actually mixes the elements in the modern screws. I'll try to show if I get an image of that in the metering section. And or you can also visit YouTube to see the screw extrusion. If it's use the keyword screw extrusion of plastic, then you will get a lot of videos or animated videos for the extrusion. Okay, then you'll see the action of the metering section. Okay, next is the configuration and extruded products. Products can be 3 types. Okay, the solid profile, that means the product of extrusion is actually called the extruded. The extrudeds can be solid profiles, like there's no hollow thing, and then hollow profiles like wire or cable coating sheets can be produced using the hollow profile, and then finally film or filaments for fiber making. Okay, these 3 types of products can be produced using the and the film is kind of different. The film is like poly bags or plastic sheets, polyethylene sheets that we use for as tablecloths for the protection of table, right? The first one is for solid cross section. This is a die for solid cross section. This part is already discussed. Actually, this is the screen that is used for screening the unmelted or providing the laminar flow from towards the screw section. And in this case, the extrusion die is a circular or solid round cross section. If we want to get cylindrical extruded profile like this cross section, then we have to use this kind of setup. And there is a thing you can see here is that the die, the length of this die has to be sufficient. Okay, there are some calculations available for this, but I'm not going to that because that will cause a lot of take a lot of time. So just keep it in mind that the length of the die has to be sufficient to provide the uniform diameter of the extruded product. Okay, and the expansion in here, if you look at the die opening, is DD is round, is smaller than the final product diameter. Okay, the final product diameter is higher than the diameter of the die. If uh, the die length is not sufficient, then it becomes very large and there will be some defects available on the surface of the material. Okay, that's why this length has to be sufficiently length, that there are calculation also available, and also there are calculation available, or sometimes the experts can gauge it, like for what size of die, for if for example if I want to extrude PVC, okay, then what should be the die diameter to get a certain diameter, outside diameter. Okay, so it depends on the calculation is also possible on sometimes the experts can gauge it, like because of their experience. Okay, this is the die opening length, LD. Then whatever the profile you provide in this die, then you will get the final product. But the problem is for the circular cross section, it's very easy, okay, to get the circular die. And after the extrusion, material actually cooled down by either air blowing or water spray, or passing the extrude to the water pond, okay, or continuously chilling water flowing through the chilling water tank. Then we can cool the out material. And about the cross section that I was talking, like to obtain a square cross section, you have to make a die like this. Isn't it interesting? If you want to make a final cross section of like a square,
Rectangular.
you have to make it like this. You have to make the die like this because of the swelling. Okay, the swelling for the circular is uniform all over the area, but for the square on the because of these corners, okay, the die has to be like this to get a perfect circular or rectangular shape. For triangle, it will be something like that. Sorry, not like this. Okay, if you want to get triangle, the die will be something like this. Okay, and it also involves some calculation and trial and error. Okay, trial and error.
Sir, is it because of surface tension during the cooling when it comes
No,
out?
it's because the material is highly compressed inside the screw. Okay, and when it gets out of the die, there is no pressure, so it actually expands. That is called swelling.
Okay, sir.
That is called swelling. Okay, because of the swelling, in the corner, swelling is less compared to the white surfaces. Okay, that is why this profile is small, is like concave. Okay,
Okay, sir.
so actually this profile is determined by kind of trial and error, and there is extensive calculation actually required, or nowadays the numerical analysis is available. So you can also do some research on this actually, for numerical analysis of the plastic soiling. Okay, and how the parameters actually changes due to that. It depends on not only the pressure but also the temperature of outlet, die outlet temperature, or the cooling method applied. Okay, so there are many other parameters, so it's a kind of good research field. Okay. The next one is for hollow cross section. If you want to produce a hollow cross section using the extrusion method, then you have to use this kind of setup, a mandrel. Okay, a mandrel to separate the material. Okay, if you look at the cross section AA, this is the cross section. Okay, this is the plate actually. This plate is mounted in here. Okay, along with the mandrel. The mandrel actually separates the material and distributes the material around this periphery, and this is if you look at the cross section, there is actually the metallic plate is here and here. Okay, material actually comes out of this plate through these three fragments, fragmented parts, and then they again combine from this place to this place. In this place, they actually, because of the high pressure, they come out and then they combine together to produce a continuous hollow shape, and that hollow shape comes out of the die. And another thing is important here is that you have to keep the air channel. You have to provide sufficient amount of air pressure through the channel to maintain the internal diameter. And what happens is that when we do Pranto Karua, Pranto Aso, Pranto, তুমি কি আসো না চলে গেছো? আচ্ছা, when we do the CRTS testing of the pipes, we can see that there's a huge variation of the thickness and at the same time the internal diameter or external diameter of the pipes. Okay, there are huge changes in these cases, depends on the company. Okay, for example, RFL pipes are very good. Okay, if we look at the RFL plastic pipes, that dimension is kind of uniform, and also the internal diameter is uniform because they use good die. It depends on the final product, actually depends on good die and good calculation. Okay, if the air pressure is not sufficient, then the diameter will change. It will not be uniform. The thickness will also change. It will not be uniform. If the die is wired, if die wires out, then what will happen is that the thickness will be changed. Okay, that is why time to time they need to maintain the quality. They need to test the thickness, and accordingly they need to vary the air pressure inside the channel, so that they can get the uniform thickness and uniform required diameter of the product. Okay, so this is very crucial. The air channel, it's very important to produce to keep the internal diameter uniform. Okay. Okay, do you have any question in here? No question?
Sir, I have a question regarding the air channel. So, is it important to have any air treatment plant, or just using the atmospheric air as a pressure fluid?
Actually, the plastic is not that reactive to the air. Okay, depends on the plastic actually. Since this air is actually in contact with the plastic, the molten plastic, right? So if the air is not reactive to the plastic, then I think there is no problem. You don't need treatment. But if it has contamination, like if you use like worse kind of air without filtering, then there might be, that might cause like irregular surface on the internal surface will be irregular, and there will be some impurities attached with the plastic. Okay.
Sorry.
Sir, is there any impact of air pressure?
Yes, of course. If the air pressure is high, then diameter will increase. That's why I was looking for you, Pranto.
Yes, sir. Thank you, sir.
When you do the CRTS testing, which
Yes,
pipe
sir.
performs better
Yes, sir.
in terms of dimension?
Yes,
Tell
sir.
me which company performs better?
Sir, Tuba
Hmm?
company pipe আমি ভালো পাইছি স্যার Tuba.
Chuba. Okay. Then new company, so they're making a really nice product. No? And usually the RFL is good. Okay. If you
হ্যাঁ
look at
RFL
the
প্রোডাক্ট ভালো পাইছি,
RFL
thickness
pipes,
ভালো।
you'll get like uniform wall thickness, and the diameter is kind of closely.
Yes, sir. Yes, sir. Yes.
Okay. It depends on actually this the maintenance of the die and the operator. Okay.
Yes.
If operator does not maintain the required air pressure, and also the melting temperature and the cooling. Okay, all these things actually affect the diameter. If there is too much air pressure, then the internal diameter will increase. Okay, and the
Yes.
thickness will also decrease. Okay, so that's why the good company actually maintains these things very nicely, and they get the good product.
Yes.
Okay.
Yes, sir. Yes, sir. Thank you.
Okay, any other question? All right, next, extrusion die for wire and cable coating. Did anyone visit the cable industry?
Yes, sir.
Okay. Then you must have seen that how the wires are coated in there. There is
It
an
actually is
Yes, sir.
inside a chamber, so I don't have the facility
Yes, sir.
to.
In BRB cables,
okay.
this type of activities
Yes, in the
I have
in the
seen.
BRB cables, we saw that. Actually, I have also visited several times the BRB cable because of the Mizan sir. You know,
Sir,
he
yes, sir.
has good contact with them actually.
Yes, sir.
Unfortunately, this year I think it's not gonna happen. But luckily, I was in Dhaka last week and I visited Superstar Group. Okay, you know Superstar Group? They're
Yes, sir. Yes, sir.
good for the LED lights and switching,
Light,
etc. They're
electric.
also, they're also producing household cables. Okay, household cables, and I visited recently in there, and they're using this same procedure, exactly same. Okay, what happens is that there is a mandrel. Mandrel actually separates the material. It becomes hollow, and wire, bare wire. That means there is no coating in this wire. The wire is fed in this way and pulled on, from this side. Wire is continuously pulled from this side, and the plastic is pressurized through the screw. The screw is pressurizing the plastic. Plastic is getting out continuously. Okay, plastic is getting out continuously on the around the wire. And important thing is that you have to use the vacuum. In the air chamber, if you use the vacuum, then what happens is that this plastic actually gets stick to the wire. And if you use, instead of vacuum, if you pressurize it, what will happen? You'll get a pipe. You know, you'll get a pipe. And
Yes, sir.
to attach the plastic with the wire, you have to use vacuum. So that plastic continuously get attached with the wire, and wire is drawn, and the plastic is attached with it, and the cooling is applied. Okay, cooling is applied either using air, cold air, or water. I saw the water is being used in the SSG group. They use a long channel, like it's very long channel for cooling the wire. Okay, and exactly same procedure is being used in there. Okay, any question? No.
No, sir.
So these are the extrusion processes for solid product. If you want to produce solid product, then these are the extrusion processes you need to use. And the common extrusion defects, what happens if something goes wrong, and what goes wrong. Okay, what is the possibility of going wrong? First one is the melt fracture. After the extrusion, this kind of irregular surface is found. Okay, and the main reason for this is that if you do not use a die of like this, gradual decrease. I think in the fluid flow you have like contraction. Okay, I think venturimeter, right, Pranto?
Yes, sir.
Venturimeter is like this, right? The contraction,
Convergent divergence nozzle.
convergence divergence nozzle. So if this is very sharp, okay, there is a sudden change, right? And
Yes, sir.
what happens here? There is a spiral, right, for the fluid flow. Rana, I think you know it very well. Rana?
Sir, converging happens with diverging that from small area to large area, then it will create a turbulence.
Yes. Like for example, if it is like gradually decreasing diameter, then the flow will be like continuous. Okay, like streamlined flow will you can obtain. But if it is like sudden contraction and fluid is flowing this way, then what happens is that the material goes like that, and there is a spiral and becomes irregular. Then streamlines become turbulent. Okay, it's not laminar. Okay, and because of this, and the surface actually fractured. There is two stresses acting when it comes out of this. this material actually rotate stays in there, they don't move, and this material moves due to the shear stress. If you look at the shear stress profile, is something like that, and the tension occurs on the surface. When the tension occurs on the surface, when coming out, okay, when coming out of the die, then due to the tension, the fracturing occurs on different points. Okay, before coming out, fracturing occurs, and because of that fracture, the surface becomes irregular. And this is the that's why to get the proper regular surface on the extruded, you need to have the continuously gradually decreasing nature of the die. Otherwise it will be fractured. Okay, this is one of the defect and one of the solution for that defect, melt fracture. Okay, any question on that, melt fracture?
Sir, I have a question regarding the laminar flow. In case of nozzle, there is no heat chamber. So it is certain that when it just touches the coil and heat itself and having the contact with the die, then it will just lose its temperature. And so
Okay.
there is a density difference between the die and the heating chamber. And in case of density change, when we are just using the meter channel to make the flow laminar from the rotational one, so
Okay.
is it possible to having a back pressure from the
Yes,
die and
from the die as well as from the screen, there is
so,
back pressure.
so isn't it unstable condition in case of laminar flow when we are having some back pressure from the die?
Yes, we are getting the back pressure, that is right, and that also included in the calculation. Actually, I did not show that, but if you read the this book, then you'll see that the total volume flow rate that's getting out of the die is equals to two parameter. Total volume flow rate, if that is Q, then QA, sorry, QA minus QB. QB is the backflow due to the back pressure. Okay, QA is the forward flow due to the screw. Screw is pushing the material forward, and due to the pressure of the screen and the die, some material getting backflow, getting some backflow. Okay, and that is why the total calculation of the volume flow rate is QA minus QB. Okay, there is obviously back pressure, but to get the benefit, we need to consider that, you know.
Sir, but my question was that as there is a temperature difference and we need to have a laminar flow, so isn't it a unstable condition like when we have a differential density for differential temperature? Isn't it unstable condition for laminar flow?
You are talking about the temperature difference from
Yes, sir.
which
Yes, sir.
point, from which point to which point?
From the heating surface to the
Heating
portion
surface,
control volume.
from the heating surface to the control volume.
Yes, sir.
Okay, the temperature difference, that's why the metering section, you know, in the metering section, what happens is that material is uniformly mixed, and the temperature actually, due to the mixing, temperature becomes uniform throughout the material. There might be a little bit difference from the outer surface to the inner, but due to the continuous rotation and rotation, this is the temperature is uniform throughout the material. And if you talk about the after the screen, are you talking about the after the screen, the material after the screen, Rana?
Yes, sir. After the screen,
After the
when
screen,
it
there is
is
a very small place. There is a very small gradient, you know, and the temperature difference is not that much because it is insulated, you know.
sir.
Outer this space is actually insulated, and the temperature difference is not much. That should not affect it very much, no.
So thank you, sir.
Okay, and the next one is shear screen or bambooing. Bambooing, does it look like a bamboo? I think so.
Yes, sir.
The
Yes, sir.
bamboo joints. Okay, and this is called, sometimes called shark screen and sometimes called bambooing. That means it looks like bamboo. Okay, and this thing actually happens due to the velocity. Okay, if there is too much pressure inside, and then the velocity profile is like this. On the surface, velocity is very low, and inside, in the middle, velocity is very high. What happens is that when the material comes out, the inner material comes out, they actually bubbles like that. And sometimes due to the friction of the die, the fracturing occurs on the surface intermittently. After some time, the fracturing starts because of the low velocity of this material compared to this material. Okay, this bubbles up and then fracture occurs and at the outside point of the die, and then bubbles up. It actually depends on the velocity. If velocity of this material is very high in the middle, it does not maintain the required velocity profile, then this bambooing occurs. Okay, that's why you need to do the optimization for the screw rotation. It actually, this velocity actually depends on the rotation of the screw. Okay, if screw rotation should be calibrated in such a way that this kind of fracturing does not occur on the outside. The velocity should be optimized. Okay. Okay, do you have any question in here? It's kind of similar, but the difference is the characteristics of the die, or the shape of the die, and the pressure or the velocity of the melt. Okay, flow velocity, if the flow velocity is very high, then bambooing occurs. If the flow velocity is sufficient, then it will not occur. And the next one is production of sheet and films. Okay, for this, what is the difference between sheet and film? Can anyone say? Here, it actually depends on thickness range. You know, the term sheet is used for 0.5 millimeter to 12.5 millimeter thickness. If the thickness of the plastic products are like 0.5 millimeter to 12.5 millimeter, they are termed as sheet. Normally used for flat window glazing or stroke thermoforming, something like that. And film,
স্যার
okay,
12.5 হবে না, এটা স্যার 6 মিলি হবে স্যার। শীট তো 6 মিলি পর্যন্ত মনে হয় স্যার।
plastic sheet.
জি স্যার।
I'm not sure. I got it from the book, actually, from the McGrover's book. It says 0.5 inch, and I think more than 0.5 inch they are actually called plate. You know, for the metals, so far I remember, it's kind of sheet, and
Yes sir.
more than 12.5
Yes, sir.
it's called plate. So it can be plastic plate. Okay, so for less than 0.5 millimeter thickness is called thin films. Okay, they're usually used for packaging, product wrapping material, grocery bags, or garbage bags. Okay, and more than half of the films are actually polyethylene, and mostly low density polyethylene. There are two types of polyethylene: high density polyethylene, HDPE, and low density polyethylene is LDPE. Okay, mostly our low density polyethylene is used for polyethylene, because of low density polyethylene has low viscosity and more flexibility compared to high density polyethylene. Okay, and the principal other materials can be like polypropylene, polyvinyl chloride, PVC, and regenerated cellulose, that is cellophane. Okay, this is a natural composite, actually, natural material, not the plastic. These are all thermoplastic polymers. Actually, the film or sheet, most of them are actually thermoplastic polymers being used here. The first one is very simple, similar to the extrusion. The extrusion up to this point, it's similar to the extrusion, and after that what happens is that depending on the size of the film, if the film size is very let's say 2 meter, then this slit length will be 2 meter. Okay, and there is a manifold. The manifold is basically used for, if you look at the cross section here from this side, okay, from this side, if you look at the cross section, then you'll see a cross section like that. After the screw, the material is collected on the manifold. Then manifold spread the material throughout this space. Manifold is actually spreads the material, and then this material comes out of a small slit, and then finally the very small die slit. Okay, and this is kind of compression continuously getting out, and the material is continuously getting out of this this sheet. Okay, it's kind of the solid solid extrusion. Okay. Okay, did you understand this? Okay, did you understand this one?
Yes, sir.
This is very
Yes, sir.
simple. Okay, it's continuous extrusion, just like that. And the cooling of this, in this case, there are two methods for cooling.
Sir,
Yes.
প্রিভিয়াস স্লাইডে স্যার হইতেছে বাউন্ডারিটা সাধারণত বের হয়ে গেল কেন স্যার? অন্যগুলো তো অন্য প্রিভিয়াস স্লাইড গুলোতে তো বাউন্ডারি বাইরের দিকে ছিল। এক্সট্রুড ফিল্মের কথা বলতেছে স্যার।
হ্যাঁ, বাউন্ডারি হুইচ
এক্সট্রুড ফিল্মে স্যার হইতেছে থিন ফিল্মটা যেটা সেটা বের হচ্ছে, সেটা ভিতরের দিকে সিঙ্ক হয়ে গেছে। আগের গুলো তো বাইরের দিকে থাকতো স্যার।
আমি বুঝতে পারিনি কি কথা, আমি আসলে বুঝতে পারি নাই
স্যার যেটা বের হচ্ছে সেটা টেনশনের কারণে স্যার চারদিকে বাইরের দিকে বের হয়ে থাকার কথা ছিল, এটা ভিতর দিকে।
এটা ভিতর দিকে এটার কথা বলছেন?
জি স্যার।
আচ্ছা, in the case of film, okay,
জি স্যার।
in the case of if you talk about the extrusion, what happens is that the material comes out of the die and then it expands like that, right?
জি স্যার।
Expands like that. In the case of thin film, what happens is the slit is very small. Okay, the slit is the die outlet is very small, and it also occurs like that. It happens like that. Okay, and on the periphery, actually in the I was going to talk about that. Actually, what happens in the boundary, on both boundary, these boundaries are more denser compared to the inner films. Okay,
Yes sir.
that also happens in the boundary, and most of the cases the boundary is cut off. Actually, that's kind of useless because of that restriction, the expansion on that side. And the expansion also happens in here too, similar to the one we saw previously. Okay.
Yes sir.
And the cooling method, there are two cooling method can be used. One is the quenching bath. Okay, when the film is comes out from the slit die, and then it moves through a roller, and then there is water or any other material for cooling, and then comes out to drying and take up or molding. And another one is called chill roll. The rollers itself are cool. Okay, rollers are being cooled, and the materials coming out, the inner surface is being cooled in this roller, and the outer surface is being cooled in this roller, and then we take up for packaging. Okay, so both method has their advantage and disadvantage. So most of the cases, this one kind of more effective compared to this one. Okay, this gives actually the faster production compared to this one. Okay, because this is stationary water and this is die cooled. The one surface is cooled rapidly, and outer surface is being cooled by air, and then the inner surface, outer surface is cooled in this roll, and it gives a very high production rate. Okay, and sometimes this film extrusion process, the slit die extrusion process, is also called chill roll extrusion process if this cooling method is used. Okay, and this cooling method has less requires less floor space compared to this, because it involves the tank and water and other things. Okay. Okay, any question? Okay, from today the lecture is going to end here, and the next day we'll continue studying other processing methods of the plastics. Okay, and I'm going to